Why are costs lower in the long run than they are in the short run? Well, the obvious reason is that you can vary capital more effectively in the long run than you can in the short run. In fact, in the short run, you're stuck with a given level of capital and you can't even vary it. Whereas in the long run, you can pick the optimal level of capital. So let's look at this in a little more detail. So let's look at a very simplified example where you could pick between three different levels of a plant size. So you can pick between small, medium, and large plant size. And based on the size of plant that you decide to build, you're going to have a different average cost in the short run. So you're going to have the short run average cost for the small plant size, the short run average cost for the medium, and the short run average cost for the large plant size. Now you could simultaneously pick the quantity of the level of labor as well as what plant size, what's the long run cost of producing Q units? Well, your long run average cost is going to be the lowest of the three average costs because you're going to pick the optimal size between small, medium, and large. So your long run average cost is therefore the minimum of the three. So let's look at a picture of that. In the short run, you've got either this average cost curve, this average cost curve, or this average cost curve. Those are your three options. But because you're going to pick the optimal of the three, you would never, in the long run, you're never going to use let's suppose this is for the small plant size, this is for the medium, and this is for the large. You're never going to, at this quantity, you're not going to pick the small plant size. Instead, you're going to pick the medium plant size. So your long run average cost is going to be up to this quantity. You're going to use the small plant size. So you're going to have this average cost curve. But between this quantity and this quantity, you're going to say, well, the best thing I can do is use the medium-sized plant. So I'm going to use a medium-sized plant, and so my average cost curve is going to be given by this. And any quantity above here, I use the large plant, so I use this as my average cost curve. So the bottoms of the three, the lowest of the three gives you the long run average cost curve. And so as we see, the long run average cost curve is never going to be higher than the short run average cost curve. Now, if you had, let's say you didn't have just the three sizes, small, medium, and large, but you could pick any size between them, then you would have some sort of a smooth long run average cost curve that would pick the bottoms of all the different possible short run average cost curves you would have. So you might have had one here, one here. You might have had all these different short run average cost curves. You take the bottom of all of those, and you're going to get some kind of a nice long run average cost curve at the bottom of that. So let's look at this with an example just to uh, get a more concrete sense of what's going on here. Let's suppose you get to pick between a laser printer, which costs you $100 to buy the printer and then 4 cents a page, or you could buy an inkjet printer, which costs you $30 to buy up front, but then the per page cost is a little higher, it's 7 cents a page. So your cost function, your average cost, if you use a laser printer, is 100 divided by Q plus 0.04. So this is the per page. If you print Q pages, this is the cost per page if you use a laser printer. And if you use an inkjet printer, this is your cost per page, 30 Q plus 0.07. Sorry, 30 over Q plus 0.07. So which one should you buy? Well, it depends on how much you're going to be printing. If you're going to be printing a lot, you're probably going to want the laser printer. If you're going to be printing a little, you want the inkjet printer. So your long run average cost curve is if your Q is high enough, then you want the laser printer. And if your Q is low enough, you want the inkjet printer. Well, how do we know what's high enough? Well, we just see where these two things are equal to one another. So for what Q is 100 over Q plus 0.04 equals 30 over Q plus 0.07. If you solve for Q, you'll find that that Q is such that if Q is bigger than 2,333, this thing's going to be smaller. And if Q is smaller than 2,333, this thing's going to be the smaller number. Because when you set these two equal to one another, you're going to get 2,333 point something. So with a picture, your average cost curve, if you look at the inkjet, is this one. And for the laser printer, it's this one. So this point right here where they're equal is 2,333 point something. And that's when the average cost is 8.25. And so for any quantity below that, your average cost is going to be given by the inkjet average cost. Any quantity above this level, you're going to have the long run average cost be given by the average cost of the laser printer. For the case of constant returns to scale technology, this phenomenon is going to be a little peculiar. Remember, for constant returns to scale, if you multiply the inputs by some number, you're going to be multiplying the output by the same number. So let's think about this point here where the average cost is minimized. So if I just multiply the output by some number, so I go from here, let's say I want to increase by 1.5. So I multiply the output by 1.5. So this is Q, this is 1.5 Q. Well, I can simply use 1.5 times the capital that gave me this short run average cost curve, and it's going to give me an average cost curve that's minimized at this point right here. And that's simply because of the fact that this is a constant return to scale technology. So the bottoms of all the different short run average cost curves are all going to be exactly at the same minimum average cost. So the long run average cost curve is actually going to be a flat line. It's going to be a straight line. So the long run average cost and the long run marginal cost are going to be exactly equal to one another, and they're going to be constant. So that's what's special about these constant return to scale technologies. Now, what does the long run and short run expansion paths look like? Well, remember, in the short run, you can't vary capital. So the short run expansion path is just going to be at a fixed capital level. So you're going to be just increasing labor if you want to increase your output. Whereas the expansion path for in the long run is going to be increasing both capital and labor. And that's why we see this demonstrates that you have greater flexibility in the long run than you do in the short run. So to get to the same level of 200 output, you're going to be here on the expansion path in the short run, whereas on the long run, you're going to be at this point here, which is on a lower ISO cost line. So we've now seen sort of the obvious reason why long run costs are lower than short run costs, which is that you have more flexibility in choosing the inputs. All of your inputs are variable. But there are other reasons why long run costs are lower than short run costs. The next obvious reason is technological progress. Over time, technology gets better, lowering costs. But the last reason that I want to talk to you about is the fact that there's learning by doing. People get better at producing a good, the more they produce. So the more output you've produced cumulatively, the more efficiently you're going to be able to produce it. So let's say, given that you've produced a certain amount cumulatively, your average cost is going to be decreasing as a function of that. So we call this the learning curve. So despite common usage, a steep learning curve doesn't necessarily mean that it's difficult to learn, but rather it means that you're making quick progress. So the steeper this curve is, it means the faster your average cost decreases as you produce more. So how does this affect your cost curve? Well, let's look at this example. So let's say you start with this average cost curve here, and you're producing this amount Q1, and so your average cost is given by this point A, capital A, on your average cost curve. Now, you produce more, so because of economies of scale, as you produce more, your average cost is going to decrease. However, because you're producing more, if you go from Q1 to Q2, there's two things that are going to happen. One is that you're going to benefit from economies of scale, so your average cost is going to decrease, but you're also producing more cumulatively. So by learning, you're dropping your average cost curve from AC1 to AC2. So instead of going to B, you would go to little b. And as you go to Q3, you would go, instead of going to C, you would actually go, you'd drop your average cost even more. So you're lowering your average cost tomorrow because you're learning more by producing more today. So your average cost curve over the long run would look more like this. So it would decrease more as you produce more.